In networking, messages are not random collections of data. They are carefully shaped. They are deliberately organized. They are structured. Whenever a message moves across a network, it does not arrive as a mystery. The receiving endpoint knows how to read it, how to interpret it, and how to act on it. That is only possible because messages have structure. Message structure is what turns raw bits into understandable communication. It defines how information inside a message is arranged, separated, and interpreted. Without structure, a message would be meaningless noise. With structure, it becomes a reliable unit of communication. If messages are the words networks use, message structure is grammar. So what is message structure really? At its core, message structure is the internal layout of a message. It defines which parts of the message provide context, which parts carry content, and how those parts relate to each other. A message is not just data being sent, it is data wrapped in meaning. Every network message contains at least two conceptual components, context and content. The context explains what the message is, where it came from, where it is going, and how it should be handled. The content carries the actual information the sender wants to communicate. In networking terms, these are commonly called headers and payloads. The payload is the message's substance. The headers are the message's instructions. A useful way to think about this is a package in a delivery system. The item inside the box is the payload. The shipping label, tracking number, handling instructions, and destination address are the headers. Delivery systems do not open the box to understand what is inside. They rely entirely on the label. Networks work the same way. Routers, switches, and intermediate systems move messages based on structure, not meaning. They read headers, not payloads. This leads us to how message structure works in practice. Message structure is defined by protocols. Protocols are shared agreements that specify exactly how messages must be formatted. They define field order, field size, encoding rules, and interpretation. When an endpoint creates a message, it follows these rules precisely. When another endpoint receives the message, it applies the same rules in reverse. This shared structure allows communication without negotiation. The sender does not explain how the message is laid out. The receiver already knows. During transmission, the network treats messages mechanically. It may fragment them, buffer them, delay them, or route them across different paths. But throughout this process, the structure remains intact. Even when a message is split into pieces, those pieces exist only to serve the original structured message. At the destination, the receiving endpoint reconstructs the message and passes it according to its structure. Headers are examined first. They determine how the payload should be interpreted, which application should receive it, and what action should be taken. The network never needs to understand the payload itself. That responsibility belongs entirely to the endpoints. So why does message structure matter so much? Because structure is what enables scale. Without structure, every message would require custom handling. Networks would need to understand application logic. Interoperability would collapse. With structure, networks can be generic. They can move messages for countless applications without knowing anything about those applications. This is why the same network can carry video calls, file transfers, API requests, and control signals at the same time. Structure also enables reliability. Because messages follow predictable formats, systems can detect corruption, missing fields, or invalid values. They can reject malformed messages instead of misinterpreting them. This predictability is what allows error handling, retries, acknowledgements, and recovery mechanisms to exist. Message structure also enables performance. Headers are designed to be small, fixed, and fast to pass. This allows network devices to make routing and scheduling decisions quickly, without inspecting large payloads. Now let's look at the defining features of message structure. First, message structure is layered. Different layers of the network care about different parts of the message. Lower layers focus on delivery information. Higher layers focus on meaning and application logic. Each layer reads what it needs and ignores the rest. Second, message structure is explicit. Fields have defined meanings and boundaries. There is no guessing where one piece ends and another begins. This is what makes automated processing possible. Third, message structure is constrained. Fields are limited in size and format. These constraints prevent ambiguity and reduce errors. They also make parsing deterministic and fast. Fourth, message structure is extensible. Well-designed message formats allow new fields to be added without breaking older systems. This is how protocols evolve while maintaining backward compatibility. Finally, message structure separates responsibility. The network is responsible for handling structured metadata. Endpoints are responsible for interpreting payloads. This separation is one of the most important design principles in networking. These structural choices have deep implications for network behavior. Because networks operate on structured messages, many familiar network phenomena emerge naturally. Latency exists because messages take time to move. Congestion exists because many messages compete for limited capacity. Packet loss exists because structured messages can be dropped and retried. Security mechanisms exist because structured headers allow inspection, filtering, and authentication. Even failures are shaped by message structure. A malformed header may cause a message to be dropped immediately. A valid header with an invalid payload may reach the application and fail later. Different failures occur at different layers, depending on which part of the structure breaks. Once you understand message structure, networking becomes less mysterious. You stop seeing networks as opaque systems. You start seeing them as pipelines that move structured messages under constraints. In modern systems, message structure is everywhere. HTTP requests, API responses, streaming protocols, control messages, distributed systems coordination. Each relies on carefully designed message formats to function reliably at scale. Message structure is not an implementation detail. It is a design decision that shapes performance, reliability, security, and evolution. Messages carry meaning. Structure preserves that meaning across distance, time, and failure. Messages are how networks communicate. Message structure is how that communication stays intelligible. That is message structure.